Okay, good morning student. Today I will discuss about the next exercise, parametric equation of the function. Before going to parametric equation of the function, we have to discuss about some natural logs or common logs. Okay, one student Divyanshi asked me to discuss how can we define the logs, what the properties of log. So one by one I will discuss about the log, then I will come after exercise 5.6. So first one is, there are two types of log. Natural log, that is called log x. If there is no base, it means e. That is called the natural log. So any log with base b, that is called the natural log, or any logs with base a or any positive integer or any positive real number, so that is called the common log. So what the condition is must be here. Natural log also called the ln of x, that is called ln log x. Whole NCERT is assuming the natural log. If there is no base, you have to assume that natural log. So mostly prefer to natural log, but sometimes we use the common log, that is the constant or any real number with base a 2. What the property of e? E less than 3 and greater than 2. E lie between 2 and 3. So these two type of logs we have to discuss. So now if you given that, suppose that log of x equal to log of base b, suppose that is the common log, x equal to y. So what the property here? B should be, that is the common log with base b should be greater than 1, always be greater than 1. And the x called the domain. If we simplify here, it means b raised to the power y, that is equal to x. So you can see that x always be positive. X belong to R positive, any real number, any positive real number, so that is called the domain. You can observe here what the domain x, what the value we can put in the log function, that is called the domain of the log function. So you can assume that what will the y? You can assume that y may be positive, any real number, any positive real number, any negative real number. So y should be, y belong to R. Is that clear? So in this property we have to use this point, we have to mind it and keep in mind this point. B should be greater than 1, x belong to R positive, any real positive number, and y is the real number. Y may be any positive. So you can see that y, for this example we can use this 3 raised to the power minus 2. So that can be right, 1/3 square, that is equal to 1/9. So that is the x. Suppose that b raised to the power y equal to x. If b, in place of b we put 3, base is 3 and the y value is minus 2, then is also positive. X always be positive. So y should be any. So y belong to R and R is the any positive real number. Okay, that is the common log. That is the property of common log. So after this we have to discuss the x. We can observe that any positive real number and the y is the any real number. B greater than 1, any real number but greater than 1 b. So this point you have to keep in mind. Okay. Now another property is that, suppose that log of x, suppose that is x, log x, that is called the natural log. In place of x with base e, a base and the number, real number is same, these two number are same, so that is called the 1. For any natural log or common log, both, any case, that is also log base a and a. If these two values are same, then the value of log will be 1 for any. Okay, similarly we can find the log b or b with base b, that is also 1. So whole values of this at x equal to 1, x equal to 1 x equal to e, sorry, x equal to e log e base e and the value of e, base a value of a, base b and base value of b. If these two values are same, then the value of log always be 1. Okay, suppose that you have given the log of x. As you know that differentiation of log x, ddx of log x equal to what will come? 1 upon x. Suppose that you have given the ddx of log a raised to the power x. That is the base e. If there is no any base, we have to assume that there is e. If we given that have two common log, that is the natural log. Natural log have not given base, it means there is e. Either you can say log x, either you can log x, either without e use log x. But in this form we have to use the property of base a. There is no difference. How can we find out the differentiation of this one? So for this we have to convert into the, so log x and so you can write the log a, log x base a, log x upon log a. We can convert the base a to e by dividing both sides in the division form, log x upon log a with base e. Okay, now you can differentiate this one. If you find the ddx, so how can we find the ddx? In this way you can find the ddx of this one. Now you can use after this you can come here. So that is the constant term 1 upon log of a, and log x you know the 1 upon x. Okay, so you can use this one, log x 1 upon x and the 1 by log a, or either you can say 1 upon x log a. Is that clear? This is the property of log a. After that we come that what the value of log 1? Any base of log 1 log a always be equal to 0 for any base log 1 that is equal to 0. Is that clear? Now come to the next on the property of logs. It's called the properties of log. Log m multiply n, that is called first property, log mn. It means log m plus log n. Okay, for example you can see that example you can use log x log 2 multiply 3. Okay, you can write here log 2 plus log 3. Okay, in this way you can write. Similarly for another variable you can use the product form of log. The next property is this one, second one, log of m by n. You already studied in the previous class, just I revise you shortly. Log m by n, log m minus log of n. So you can observe that there is no base. There is no base. You have to assume there is base is e. If there is no base given, you have to assume there is e. That is called the natural log. NCERT book you have to given all logs in the base of e. That is called natural log. So mostly you have to use this one. Come to the third property of log m by n, log m raised to the power n, exponential form of log. So what the property this one? This power will come in the previous part, n log m. Okay, these are all about the multiply, divide and the exponential form. So we have to use only these three part of log. Okay, that is clear. These are all about the log which have you studied in the previous class also. Just I have revised shortly. Okay, after that we will come to the chapter 5.6. Form of differentiation. There are two functions in the form of x and y with common variable and variable t. Suppose that x equal to at square and y equal to 2at. You can say that there are two functions in the form of t. X is one first function and y is the second function. Both function in the common variable, that is t. So in such a case, how can we find the differential dy by dx? So to find the dy by dx, how can we find in parametric form? These equations are called parametric form. We have studied also parametric in the previous classes in coordinate geometry. I have studied the parametric form, parabola and coordinate geometry. So this is the parametric form. Now we have to discuss about the differentiation of parametric form, parametric equation. So x is another function and y is another function. Both function with common variable, that is t. That is called third variable. If two functions are given in the third common variable, then we have to find the differentiation. How can we find? So first you write dy by dx can be write as, if we divide by dy by dt and dx by dt. So dy by dt and dx by dt. So you can see that there is a x and there is a t. If we differentiate both sides with respect to t, we can find the dx by dt. Suppose that you have given x equal to at square. Let this one example, x equal to at square. So for dy by dx we have to convert in this one. So for that we have to find the value of this one and we have to find the value this one. Then we put these two values. In this way we can find the dy by dx. So dy by dt, how can we find the dy by dt and dx by? First we find the dx by dt. So x is given you t square. It means differentiation of x with respect to t. What does the mean of this? Differentiation of x with respect to t. Here is t. Differentiation of y with respect to t. It means, so derivative with respect to t of y and x. So first we take the x and differentiate. What can we write? Differentiate both sides with respect to t. Okay. Now dx upon dt with respect to t. So we have to differentiate both sides. Dx upon dt, that is called the, a is the constant, a into ddt of t square. Okay. You can find a into 2t. And the differential of t with respect to t, that is 1. Okay. So all about that is come to at. Okay. Similarly dy by dt, y is given you, what the y is given you 2at. So now find the, so dy by differentiate both sides. Yeah, here we can write y equal to 2at. So I'll differentiate both sides with respect to t. We have to differentiate both because we need to dy by dt. Dx by dt already obtained here from this function. Now we have to need dy by dt. How can we find? If differentiate y with respect to t, we can find the dy by dt. So differentiate both sides with respect to t. Dy by dt equal to 2a is the constant and the variable is t, or the variable t. So ddx ddt with respect to t, ddt of t, that is equal to 1. That is equal to 2a into 1 and that is equal to 2a. Okay. Now put these two values here. So dy by dx equal to, what the value of dy by dt? 2a, and dx upon dt 2at, that is equal to 1 upon t. Okay. That is the, so dy by dx equal to 1 by t. This is called the parametric equation, definition of parametric equation. Is that clear? So in this way you can find the question number first you can do first, second and third. Okay, now I've come to second question. X equal to a cos 5.6. Question number 2. First I have done in the first question you can do as the example I have given you just now. Second I am doing for the trigonometrical function. First given you x equal to a cos theta, x equal to a cos theta, and y equal to what given? Y equal to b cos theta. Y equal to b cos theta. Now you have to find out the dy by dx without eliminating the parametric. What the question? If x and y are connected parametrically, you can see that x and y are parametric connectively. Connectively means common variable. Common variable is theta here and theta here. So that is called the connective with parametrically, x and y. So x and y are connective parametrically. And what is the third variable? That is theta. So that is called the connected parametrically, and given without eliminating parameter. Without eliminating theta, we have to find out the dy by dx. You already know. So now you can observe, we have to find the dy by dx, and the third variable is theta. X is also related to theta, y is also related to theta. So common variable there is theta. Now differentiate both with respect to third variable. So dy by differentiate y with respect to theta. That is called the dy by theta. Dy by d theta, and the x will come in denominator. Differentiate the x with respect to theta. Okay, in this way you can find the dy by dx. So now take one by one. X equal to a cos theta. So what can we do? Differentiate both sides with respect to theta. So what will come? Differentiation of x with respect to theta. Differentiation of x with respect to dd theta, you can say it in shortly, and a is the constant to dd theta. What we are using with respect to theta, so denominator always be d theta will come. A is the constant, and the cos theta, differentiation of cos theta. What the differentiation of cos theta with respect to theta? That is come a into minus sin theta. You can say minus a sin theta. Okay. Similarly, you are obtained here. First you have already obtained. Now come to the second, dy by d theta. How can we find? You have given the y equal to, that is equation number 1. You can say y equal to b cos theta. Now same as to differentiate with respect to theta both side. So dy by d theta, b is the constant, dd theta of cos theta. So what the differentiation of cos theta with respect to theta? Minus sin theta. So you can write minus b sin theta. Equation number 2. From 1 and 2 you can put the value here. From equation 1 and 2 put the value here. Dy by dx equal to dy. What the value of dy by d theta? You can say minus b sin theta. Minus b sin theta. Okay. And the second, dx by d theta. What the value of dx by d theta? You can observe here. Minus a sin theta. Okay, it means b upon a. So implies that it means dy by dx equal to b upon a. Is that clear? Okay, can you do in this form? There is a variable. Sometimes you given the theta, sometimes you have given the t, sometimes given the another variable. So you have to do same manner. Okay, now come to the next question. You can note down by pausing the video. Pause the video and you can write it. So in between you have to, if you need the latest update, you have to subscribe the channel and press the bell icon. Otherwise you will not able to get the latest update randomly at once. If you want to take at once latest update for our channel, for our videos, you have to subscribe the channel and press the bell icon. Remember it and ask to the other students. Okay, after that come to the next question. Fifth you can do. Fifth also same as it is. Fifth, sixth, seventh in same manner you can do. I am doing just 6 questions. 6 I have given you. Question number 6, what is given you? X equal to A into bracket theta minus sin theta. Theta minus sin theta. And the next one, y equal to A into 1 plus cos theta. Y equal to A into 1 plus cos theta. So can you do same manner? I am doing just shortly, just listen here. So you have to find out the dy by dx without eliminating the parameter, without eliminating the theta. So what can we write? Dy by dx. What the third variable here? Theta. Third variable is theta, and the both function x and y in terms of theta. Now we have to find the with respect to theta. Dy by dx. So y, if we differentiate the y with respect to theta, that is come dy by d theta. Similarly, come to the x dx upon d theta, that is equal to dy by dx. So first you differentiate the x and y. Now let 1 y is given you a into 1 plus cos theta. So differentiate both sides with respect to theta. So what will come? Dy by d theta equal to a is the constant. Now d theta of 1 plus cos theta. It means you can differentiate that a, what the differentiation of 1 0 and cos theta is the minus sin theta. It means minus a sin theta. Clear? Second one is given you. What the given you? That is equation number 1. You can say first. Now come to the next one. What is given? X. X equal to given the a into theta minus sin theta. You have to, how can we find dxy? Differentiate with respect to x. यहाँ लिखेंगे differentiate both side with respect to theta. So dx upon d theta is the constant separately, and now dd theta of theta minus sin theta. So we can differentiate here a, what the value of theta, that is 1 with respect to theta. Suppose like that, differentiation of x with respect to x 1. Similarly, differentiation of theta with respect to theta, that will also will 1. That is 1, and sin theta cos theta. Okay, differentiation of sin theta will be cos theta. So these are two values. So you can assume that now what we have to do, put the value here, dy by dx. What the value from equation 1? You can write from equation 1 and 2, dy by dx equal to dy by dx. What will come? What the value of dy by d theta? You can here see minus a sin theta, or value of dx upon d theta from equation 2, a into 1 minus cos theta. You can cut here, simplify. So minus sin theta upon 1 minus cos theta. In this way you can find the value. Any more question about this? Otherwise you can or simplify other more to match the answer. If you want to match the answer, you can simplify. What the value of sin theta? Minus sin theta means 2 sin theta. 2 sin theta by 2 into cos theta by 2. And to eliminate this one, 1 minus 2 sin square theta by 2. So you can write minus 2 sin theta by 2 into cos theta by 2 upon 1 minus 1 plus 2 sin square theta by 2. You can see this cancel will, and the square will also cancel, and the 2 also cancel. So what will come? Minus cot theta by 2. Okay, these are all about the 5.6. You can do more after this question.